What is up, folks? This is Mr. Walker here coming to you with our next lesson. We're talking about compositions of transformations on a coordinate plane. Let's get into it. So, we've done four different types of transformations. This lesson is about mixing them all up and going through it. Okay. So, first off, let's define what this is. So, composition of transformations occurs when two or more transformations are combined to form a new transformation. Now, we're going to go through two of these and then we're going to make a brief conclusion. We're going to have to expand on it a little bit before we move on. So, let's take a look at the first one that we got here. All right. So, for this, we got two transformations happening to our triangle ABC. Our triangle ABC is going to be reflected across the y-axis, and then we are translating it. In our translation, we got our x is being subtracted by 4, and our y is being added by 2. So this is going to be moving to the left 4 and up 2. So let's go through. We're going to see how this works. All right, first transformation, we're going to reflect it here. Before we move on, I want you to notice a couple things. The notation is going to start to change the more transformations we get. So the first transformation we had, let me go back, was this reflection. Note that we went from ABC to A prime, B prime, C prime. So each of these letters has one apostrophe added on. When we looked at the final shape, A now has two apostrophes, B has two, and so does C. When you see the number of apostrophes, my bad, the number of apostrophes on each of our vertices, that lets you know how many transformations have occurred. So if we saw two, like how we do here, that lets us know there was two transformations that happened to this shape. If we saw three, that'll let you know three and four and so on. We're probably not going to go on to like four because honestly, having an A with four apostrophes on a coordinate plane can get kind of confusing. All right, let's take a look back at our other example. Now this time we still have the same triangle ABC, but what we're going to do is we are going to translate this first and then we're going to reflect across the y-axis. So first thing we got, ABC is slid over to here to the left, and then we're going to reflect it over the y-axis. So reflecting it over the y-axis brings us over to here. Okay. Now, what's a quick little thing that we're noticing here? These are still the same transformations. We're still reflecting over the y-axis. We're still translating the same way, but our final shape did not end up in the same place. Okay. So as a conclusion, the order of the transformations in a composition does matter. The composition is not communicative. If you don't remember what communicative is, that means that you cannot switch around the order for this and get to the same place. The order does in fact matter. Okay. All right. So now that we know that the order in fact matters for this, let's get into some more notes. So first thing we want to go through is talk about a particular type of transformation. This is called a glide reflection. So a glide reflection is a name for a composition of translations and reflections. where the line of reflection is parallel to the direction of the line of translation. So essentially, we got a line here that we are moving along for our translation, and you note that it is going in the same direction as these footsteps that we have here. When we're doing a glide translation, as long as the line that we were reflecting over, which is this line here in the middle, is parallel to the same direction that we are sliding our shape to, then this will end up being the same shape no matter where we move it to. This type of composition is the only one where it is communicative. Okay, that means that you can go through and do either one in either order if they tell you ahead of time that the line of reflection is parallel to the same direction of our line of translation. So if those two lines are going in the same direction, then you can do either one in any order. All right. Okay. So folks, let's get into some practice. We got how many of these? Let me double check our paper. All right, we got two on the side and we got two on the bottom. We're going to do the two on the side first. Okay. So over here on the side, we got two transformations that are happening. First one we got is we are rotating 90 degrees about the origin. Then we are doing this translation. We are moving to the left by 4 and moving down by 1. So when we do this, we want to do this one at a time because the order in fact matters. So we're going to first do this, then we're going to do this one. Okay, let's go through. Let's talk about it. All right, first one we're doing is rotating 90 degrees about the origin. If you remember how rotating works, it's essentially move one quadrant over for 90. We go two quadrants over for 180, and we move three quadrants over for 270. And if you have to do 360, which we don't really do, 360 brings you right back to the starting point. So first thing we're going to do is we're going to rotate this around the origin. Now you have the rules for these. I'll remind you, make sure you're using your notes. Okay. So first thing we want to go through to do, let's do our rotation. And let's make note of our original points so that we can do this. So we got -1, -1, 0, -7, 7, -5. All right, first thing we're doing to this is we are going to rotate it, which is going to move our shape from being down in quadrant 4 to coming up on quadrant 1. So note that the F, since it was crossing the y-axis, F prime is going to cross the x-axis in that same, orientation. G was on the y-axis, so G prime will be on the x-axis. And H is pointing right. If we turn it, it's now facing up. All right, so that's our first change. Next change we got is we are sliding this new shape here over to the left 4 and down by 1. So moving to the left 4 and down by 1 brings us to our new shape here. We got F double prime. Sorry. Yeah. Is it F double prime? Yeah. F double prime, G double prime, H double prime. So this is our final resting place for this. So noting the points for it, our F double prime is -3, -2. G double prime is 3, -1. And H double prime is 1, 6. So make sure that you go through this one thing at a time. Okay. All right. Next one we got here is on the bottom part of the right side. We got rotating 270 degrees, and then we are reflecting our shape across the x-axis. So here's where we're at currently. If we rotated at 90, our shape will be somewhere around in this vicinity. 180, 180 would bring somewhere around here. 270 should be somewhere here. So we are going to rotate it all the way around to here. and then reflect over the x-axis. So first off, let's note our points for our three corners. We got J at 8,1, K at 2,3, and L at 4, -6. All right, first thing we're doing is we are rotating this around 270. That's going to pop us off right over here. So like I said, we rotate all the way around. It's in this general area. Now, if your shape happens to touch your original one, don't think that you did something wrong. Sometimes it happens, okay? So we go through, we got our first transformation done. Then we're going to reflect this across the x-axis. Remember, when we reflect across the x-axis, these different points are going to be kind of parallel to each other. Wherever you see J at, you're going to see J prime at. Well, sorry. Wherever you see J prime, you'll see J double prime. I forgot we're doing a new notation. My bad. We got L prime, L double prime, K prime, K double prime. And with that, we got our new points. So make sure that you mark those up right there. You got two more that are on the problem. Yeah, you got two more that are on the bottom for you. Sorry about that. Make sure that you go through and get those done. And I will catch you for our next lesson. See you later.